So, good afternoon, everybody. It's like in a school, right? Like a school teacher. The bell is ringing, and then sort of the new class starts. So, my name is Ulrich Stimming, and I have the great pleasure of teaching you for 2 days, today and on Friday. And this course is actually by Professor Chen about applied electrochemistry, and she has asked me to take over 2 sessions because she just wanted to relax a little bit, right? Say, okay, oh, there's this guy coming from the UK, so he can teach a little bit, and then I can relax a little bit. Now, it's actually a great pleasure, and it's also an honor for me to be here and teach you. Especially yesterday, I had actually a visit in the museum of USTC, and actually with this beautiful lady and with this beautiful young fellow, and I was impressed looking actually at the pictures of the professors and teachers here at USTC, and most of them became 100 years old. So I think there's a secret actually within this university that when you are teaching to students here, you become very old. So it means that the students are really great, because if they would be bad, then the teachers would get upset, and then when you get upset, then it's not good for your health, right? So, but if you have very good students that take everything you're saying and think about it and learn it and then carry on with it, then the teacher is very satisfied and happy about it, and then the teacher becomes very old. So I would love to be a teacher here, not only for 2 lessons, but maybe even for a longer time, because it probably will allow me to become also as old as the teachers are here in USTC. Now let's see what comes out of it. But let's do actually sort of 2 courses or 2 sessions this week. And as you know, this is about applied electrochemistry. And we want to focus actually in these 2 sessions on the number of topics, and I have listed those you see this in the next slide, actually the outline. And there are a number of things that have to do with fuel cells, the materials for fuel cells, like the membranes, talk about low temperature and high temperature PEM and alternative concepts. But I have to tell you, we are starting actually sort of only with this part. The high temperature PEM I will actually do separately on Friday. Then we will carry on with some other materials for fuel cells, such as catalysts and electrodes for hydrogen PEM fuel cell, and then talk about hydrogen generation and storage. And in the Friday session, essentially we talk about, and this is sort of gray here because this is not what we are covering today, but just to give you an overview, alternative energy carriers, a question about direct ethanol or direct alcohol more generally, fuel cells, then actually carry on with that. And then in the end we are going to talk about not so much energy conversion, but rather energy storage. And we are going to talk about the concept of redox flow batteries, which is a concept that is fairly easy to understand when you understand how the fuel cells work, because it's very similar in its functionality. So that's essentially the program we are having for these 2 days, today and on Friday. And in order to get started, and in order to get you going, because I know you come in here and it's cold and you're freezing And when you freeze, then maybe your brain is also a little cold, and you're not attentive enough, right? So what I wanted to do with you as a starting point is discuss actually two aspects. Why do we talk so much about energy today? And why do we talk so much about environment today? And you know, when you read the paper, when you talk with your fellow students, when you talk actually with your teachers, with your parents, these topics of energy and environment play a fairly important role. And we just want actually to discuss that for, let's say, a few minutes together. Why is that? What are the reasons that we talk so much about energy, and why do we talk so much about environment? And what we are going to do is, we have here the blackboard, or actually a green board, and we will put actually some notes on there. So you have now 3 minutes to think about it, make little notes for yourself about the two questions, and then after the 3 minutes we will discuss that, and I will sort of ask you what your opinions are about these two questions. Okay? So we get started. You see, we are 7 minutes past 2, and 10 minutes past 2 I will ask you actually for your suggestions. Starts working, right? No. Yeah. No. It's warm. But it takes some time before it goes on. So 1 more minute. Okay, I think we can get started. So who want to give me some suggestions. So, and then I put this down here on the blackboard. Maybe we start with the first question. What about the first question? You want to tell me something? What's your suggestion? Why do we talk so much about energy?
I think that most of the energy sources we use today from oil and carbon. And we should mitigate limiting the energy will be used up only in the future. So we need to find some other energy source to replace them in the future. Which depends when we use oil or carbon, we have some pollution to the environment. And we use that for cheaper living in the world. So then we need to find some more cleaner energy. Like hydrogen or energy from wind, from water.
Okay, so let me take the first point. I think it's very important. What we want to do is change from carbon-based to non-carbon energy, right? And so you mentioned actually this, but then you mentioned some aspect also about the environment, because this is connected with environmental effects, right? So the consequence is we want to reduce the pollution, right? So let me put this down. Reduce pollution. Okay, thank you. Okay, any other suggestions? Yes, please. Okay, so let's leave this as an important point because I think it's I don't know if you understood this properly. This country, China, needs actually a lot of energy and needs to increase even the production of energy, electricity specifically, because it has to develop its industry and the standard of living. So, and then the question is, where do we take this from, right? So let's just put it down and say society, and this is like the industry plus the people, needs more energy. Okay, and then you have addressed also this question of environment in the sense that the resources we have in China are resources based on carbon-containing energy carriers like coal. There's a lot of coal in the country, and so that is part of actually the problem. That means energy resources are based on coal. Okay. So that is like describing what the current situation is. And then what we need actually to do is to consider, where do we want to go to? What should be our future? can China go on in building more and more and more coal power plants, for instance, or use more and more oil to burn it in cars, or what's the alternative? So can you say something about what should be actually our future in that situation? Oh, it was said already. Actually, both of you have said something before, actually mentioned this already. So what do we have to use in the future?
Well, I think we should get our energy from the sun and the ocean. I think there are two biggest energy sources that we have the sun and the ocean.
So use solar energy from sun
Yeah.
and ocean.
Okay.
Okay.
If we can do that, we won't have any problem.
Then would be a good situation already, right? What would be actually an additional resource which we can use, and actually which is used already in China, but to a much lesser extent? Wind energy, right. So we should use actually all available resources that are come from nature, and that sun, ocean, let's say wind. I mean, we all know that the wind is due to the sun because we have different temperatures, we have different densities, and that creates actually the motion of air, and that's eventually then the wind. So the original source is the sun, but the way we use it is a different way. Here we can use it as thermal energy or electric energy. Here we can use it as mechanical energy that we convert into electrical energy. But there's actually even one more possibility to use energy from something that is not coal, not oil, not natural gas, and is actually a very important resource. Sorry? Nuclear, right? We have not talked about nuclear so far. Although one has to say that nuclear is not a renewable source in the sense that it sort of comes from nature, like sun and wind and so. That's additional one. And then there's still one more. One very natural one. Fuel? No. Biomass, yes, right. Look out of the window. This actually, plenty of that is around. You travel and you find a lot. Biomass. Okay, so we have actually quite some collection of possibilities avoiding carbon-based fuels. Sun, ocean, wind, nuclear, biomass. Maybe that's even enough. Maybe we can manage this way, right? But we have to look at this. We have to look at the possibilities to use these energies. And that's part of what we want to do here. Now, let's complement this one here as well. And maybe, as our last point, to see when we have all these alternative energies, what does it mean for the environment? Are they all, let's say, good for the environment? Or are there actually some that may have a problem? Just look at this. We have the sun, we have the ocean, we have the wind, we have nuclear, and we have biomass. Do you see any problem with sun? Using the sun as a source of energy? someone does this, well, I also would say no. I don't see actually major problem. Okay, let's go to ocean. The ocean can give me tidal energy, so I have a high tide, low tide, and that difference can actually drive a turbine and give me energy. I can also use wave energy. When I have waves at the coast, then this is both kinetic energy, because I move the water actually towards the coast and the waves go up and down. It's both kinetic and potential energy. Okay, any problem with that? No? Okay. Then let's come to the wind. No problem. Except maybe some birds may have a problem with that. It's a competition to the birds, right? But, well, no major problem. Now we come to, we come to nuclear. Any problem with nuclear? Environmental problem? The radiation. So what would be the problem then with that for the environment? Essentially, you have to take care of two aspects with the nuclear energy. Radiation, you have to shield the operation of a nuclear reactor regarding the radiation, so that no radiation actually goes out. But we may be able to take care of this. That should be okay. But then there's a second point. You need to take care of the waste, the radioactive waste. And that, in fact, may be a problem, because so far nobody has actually ever found a solution for what to do with nuclear waste. No country there is a concept for it. So there may be actually some issues here. And then what about biomass? What can be a problem with biomass? Anybody that sees a problem with biomass? Do you know about the situation in the United States of America? They have a lot of corn grown actually in the fields in order to have the corn to produce ethanol, and then they mix the ethanol with the gasoline. So then they need not to put as much fossil fuel in there, and so they use biomass actually as a source for driving the cars. And what's the consequence of that? Is that the prices for corn, world market prices, go up. And then some poorer countries have to pay more money actually for corn to feed their people. And so that's a problem. It's definitely a problem. Because the Americans want to drive their cars, some other people have to starve because they can't afford the food anymore. So one has to be very careful with biomass that you don't compete with food production. Okay, so we have to put some question marks actually to nuclear and to biomass, taking into account what potential problems are. And let's list this here on the environment. Is for the nuclear, the question of nuclear waste and the question of radiation. And for the biomass, we have to say no competition with food production. Okay, so I think that was like our initial little exercise to just sharpen our mind actually about the problems that are associated with energy in terms of the resources of energy, as well as the question actually what it has to do with the environment. Okay, and now let's sort of carry on and sharpen again our mind a little bit regarding the various possibilities we have in terms of converting energy into other forms of usable energy. And you see here on the left side the listing of actually of different sort of sources: chemical energy and fuels, nuclear energy, solar energy, heat from soil and atmosphere, and mechanical energy from wind and water. And on the other side, on the right side, you see actually forms of energy that we are using. We want to have heat. We don't want to sit in a cold room, especially when it's freezing temperatures outside. We want to have light when it's dark outside. We want to have electricity to run our TV and our telephone. And we want to have kinetic energy because we want to go from one place to another place and use the train, use the car, use the bus, whatever. So these are actually all kinds of energy which we want to use for our daily life, and that makes it easier. And now we have to consider actually which energy can be converted in which other kind of energy. And you see actually for the heat that the sources can be chemical energy by burning it, you burn a fuel; nuclear energy by having actually a reaction going, nuclear reaction going, or solar energy, you know, solar heaters. And then there are other forms for light and electricity. Actually it comes out a little, can you see it? It's a little faint actually. So it comes essentially from all parts: chemical energy, solar energy, heat from soil and atmosphere, and mechanical energy, and that leads then to light and electricity. And then the last one, the dashed line, is to arrive actually at electricity and kinetic energy from chemical fuels and chemical energy, as well as from nuclear energy. And what it shows is actually there's a multiplicity between these sources and these energies that we want to use actually in the end. And let me give you one example of illustrating this way of conversion of energy that's shown here, and that is typical actually from our today's situation. So you use a primary energy, let's say you use coal, you do the mining, and you have a processing actually of the coal, and then you arrive at the energy carrier, and then you burn this, produce heat, and the heat actually makes steam out of it. The steam runs a turbine, the turbine runs a generator, and you arrive at electrical energy. So you see there are many, many steps in between that need to overcome to get electrical energy. And then this electrical energy is distributed from the power plant actually over the grid to the various locations in the countryside or in the city through a high voltage power line. And then you have a transformer station, and then the electricity arrives at your house. You have a power plug, and then you put your let's say your lamp into the outlet, and with the electric bulb you essentially get light. This is what you want to have, and this you call this effective energy. And what you get out of the power plug is the usable energy, because that can be used also to make heat and light. So you see that the way is very long from the primary energy, let's say like coal, which is mostly here in China, to my effective energy, that I sit on a chair and can read my newspaper. So it's a long way to get this effective energy. And so a goal must be to reduce all these steps to fewer steps, to have a higher efficiency, and use something as a starting point that is environmentally friendly and doesn't interfere with the environment. Now there's one source, and we have listed this here, that's the sun. The sun actually, looking at that situation, is sort of interesting. When you look at the total energy that you get from the sun on Earth, the flux of solar energy towards the Earth is about 10 to the 24 joule per year. It's a huge number, I mean, very hard to imagine it. But you can compare this, for instance, with the energy consumption by mankind per year. And you see that's about 10 to the 20th joule per year. So the difference between what we need on Earth and what we get actually with the solar energy is a difference of 4 orders of magnitude. So the sun actually every year gives us 10,000 times more energy than we really need. And then you can actually look this up in a few other possibilities. This is just the sun. And then you can also look at hydropower, which is 3 terawatt. The kinetic energy of wind and waves, we just spoke about what the ocean can give us, it's 370 terawatt. So it's a lot of power, actually. Watt is a power, right? Terawatt. And then when you look at the sort of the power that's being used, sort of the energy converted by mankind using fossil fuels and nuclear power is just 15 terawatt. So what you see from this comparison is the supply of energy by nature in the sun and all kind of other things we have actually looked at is plenty, and we just need to use it, right? Nobody can tell us there's not enough sun, or there's not enough wave energy, or there's not enough hydropower. This is not true. And this is actually shown in these numbers. Now, but the situation actually is sort of different. Our situation is still that we use actually electricity that is mainly produced on the basis of fossil fuels. And here you see actually in the table some numbers, and also in this pie chart here, if you just add up coal and gas, then you get actually almost 60% is based on coal and gas. So only 16% on hydropower, 15% on nuclear, and then even here some more oil. So we are majorly dominated by fossil fuels, and that's part of our problem. That's part of the problem that we have actually with the CO2 emission and with the climate change. And this is pretty much the same kind of representation, but actually shown over the years, and illustrate. This shows the total electricity production in the years and the prediction for the coming years. And you see actually that this steep increase for worldwide electricity production. And when you look at the renewable electricity production, this is this box here, the top blue box, then you see that this actually increases, always increases. However, when you look at the total number, the total electricity production goes up even steeper. So the consequence is that the percentage of renewable electricity production actually in 1980 was 22%. And then year by year, it actually went down. So that shows the problem actually. That's an uphill battle to convert coal-based electricity production to renewable electricity production. So it shows it does not happen by itself. We have to work very hard to make it happen that not only 16% of the electricity are produced renewably, but let's say 60%, 70%. So the majority of electricity comes actually from renewables. And as already said, when you use fossil fuels, you have the problem of emissions. And these are sort of the gases that contribute actually to the greenhouse effect. And this is to 50% the CO2, and that comes actually from all kinds of sources like power plants and transportation, ships, cars, buses, and so on. There are also other elements. You see here methane is a very effective greenhouse gas, and the halogenated hydrocarbons. So there are actually a number that contribute, but CO2 is the largest. And this shows actually what the sources are for CO2. It's traffic, it's electrical power generation, it's industry and households. And you see that the electrical power generation is by far the largest of these contributors to the CO2 emission. And sort of people have actually started some decades ago to monitor this situation, and sort of one way actually of doing it is measure the CO2 concentration in the atmosphere. And this shows an observatory actually on the Hawaii Islands in the Pacific Ocean. And here you see the record, what they have sort of found out. This is for the past, let's say now 10 years or so. You see some fluctuations within the year, but you see there's a steady rise in CO2 concentration. And there are other sources where you can actually trace this. You can go back to 1960, and you see here the change from 320 is the basic level to 390, 2010. And you see the curve does not bend down and becomes constant, but it goes actually steeply up. And the interesting thing is some people actually have sort of different opinions on this. Actually, there was some comment that recently, maybe you have heard about this, more a joke actually even, that the new president of the United States actually in the campaign of becoming a president said, oh, this with the climate change, that is all nonsense. Actually, China just is saying this because they want to damage us. But he should know better, right? And that was actually only good for laughing, right? Because it's not true at all. Anyway, looking actually at some data that go back 1,000 years. And you can do this by looking at ice cores in the Antarctic or in the Arctic. You do cores and then you analyze in the different layers how much CO2 is there. So you can trace back actually how was it in former years about the CO2 content in the atmosphere. And it's very interesting to see that this is more or less steady, you see here. And then it's around the beginning of the 18th century, you see this increase here happening. And the 18th century, sort of the first half of the 18th century, it was essentially in Europe and in America the start of industrialization, where they use coal for power plants, for electricity production, but also for making iron and steel. You use actually a lot of coal, and that sort of, with the industrialization, that increase of CO2 took place. And I think it is not true to just blame someone on this. Again, one has to be careful when you analyze these data, and I quickly show this. You see over the years always large fluctuations. has a lot to do with the fact that there are different weather conditions and a different distribution around the Earth. But you see that when you follow the average values over the years, then you can clearly see the increasing trend of it. And the consequence of increasing the CO2 essentially is that the greenhouse effect takes place, and the greenhouse effect means when you have CO2 in the atmosphere, it allows actually solar radiation to penetrate and arrive at the surface of Earth, but the reflection of heat is hindered. This is like a greenhouse. That's the reason you use greenhouses, to have it a little warmer than it's outside, so then you grow your vegetables. What's good for the vegetables is not good for the people and not good for the environment. And what we have to notice is that the temperature in fact increases. There are fluctuations again, but the trend is clear, especially over the past 25 years, where you see actually this increase in temperature. You see here 0.5 degrees. You know that the United Nations and together with all the countries have really very much discussed this and have said we can actually sustain on Earth about 2 degrees, but not more. So we have to see that we limit the temperature rise to 2 degrees. Now, when you look at this, the number where we have actually achieved 1 degree already. The difference between here and here is about 1 degree. So there's only 1 degree left. And looking at this slope, how steep that is, it's a bit scary. So we really have to hurry and not wait too long, that we decrease the CO2 emissions so that the temperature rise is actually stopped. This is actually another chart showing the fluctuations, showing the mean value, but very clearly showing the overall trend of rising temperatures due to the increasing CO2 emissions. And this is actually a map, a global distribution, that shows where are the sources actually of major CO2 emissions. Actually, it's even quantified here. And you see it's sort of the eastern part of the United States. You see here, this is Europe, Central Europe, Eastern Europe, UK, but also Southern Europe. Then here Russia, and here you see China. China is major emitter, and here you see Japan. A little bit actually in South Africa, a little bit in Australia, but not as much. So these are the major centers actually for CO2 emission, and that definitely has to be modified when we want to sustain our climate.